Hello everyone and welcome to Coding Cart. So in our previous sessions we have solved few problems related to the graph. So the problems were connected components count in undirected graph. One problem was print connected components and the last problem was to find the largest component size. So all these three problems were interrelated with each other. So I hope you have gone through this problem. So the main idea behind explaining this problem was to solve this HackerRank problem. So if you see under this section interview preparation kit, under this graph we have this problem roads and libraries. So just go through this problem once from your end. So if you go through this problem you will find that this problem is almost similar to the last problem, like 95% is done here only with this problem, finding the largest component or finding the component size. So just go through this problem, and I recommend you, if you haven't watched these three videos, so stop this session and go and first watch these three videos and again come back to this problem and try to solve this from your end first. I hope you will be able to solve this one, like 95% is already done here only in this three problem concept only 5% is left. That is very simple concept. So let me explain you here. Here we will be given four things. One is n, which is number of cities. M is number of roads connecting those cities. This is cost of making a library, and this is cost of making a road. These four things. Suppose X and this is Y. So the problem states that we will be given a cities, okay, which will start from 1 to n. So values are 1, 2, 3, 4, 5 and 6. For example, suppose there are 6 cities. So the question states that either we can create a library in each of these cities where every individual can access, or we can have a common library and we'll create a road connecting each and every city so that every city's people are able to access that common library. But we have to keep in mind, if we are creating a common library and connecting a road, so the cost should be minimum. So for example, suppose if cost of making a library is rupees 5 and cost of making a road is 10. Okay, now suppose, let us take this scenario. Let us take this scenario, this one. Suppose there is two cities, city 5 and city number 6. Now if I am going to create two libraries, suppose L1 and L2, so my cost will be here rupees 5 and rupees 5, and this is individual library in individual cities. So every individual from this city can go to that library and every individual from this city can go to that library. So here my total cost is how much? Rupees 10. Now second scenario will be, this is city 5 and this is city 6. Now if I create one common library over here and create one road, so my cost for making the library will be rupees 5 and cost for making this road will be 10. So my total cost will be how much? 15 rupees. So we want to go with this approach because my cost of making a library and making a road is 15 rupees. But if I make a individual library in both the city, my total cost will be 10, which is minimum. So this is the question, like we have to minimize our cost. Either we can have individual library in every city, or we can have a common library and a road connected to each and every city so that every individual from every city is able to access that library. But the thing is, we have to minimize this cost. So this is the problem. So if I explain you again, suppose we have a node 1, 2, 3 and suppose 4. This was 5 and 6. So I hope this condition is clear. The very first condition was if my cost of library is less than or equal to cost of making road, then we will simply make what? Make a library in each city, right? With the above example, if my cost of library is less than or equal to cost of making road, we'll simply make a library. No need to make road, connecting roads, right? So this is one criteria. We'll simply check if the cost of making library is less than cost of making road. We'll simply go for making library in each of these city. So that will be our answer. We'll simply count how many cities are there, right? So in this scenario, where cost of making library is less than equal to cost of making road, what we will do, return, we'll simply return n into cost of making the library. This will be our answer. No need to do any calculation or make any connecting roads. So this is very clear in a simple way. Now, now let's go for the next scenario where cost of library is rupees 10 and cost of making road is rupees 5, and we have node 1, 2, 3 and 4. Okay, now if I make a common library over here, so my cost will be how much? Rupees 10. And if I make a connected roads, which will be 5 rupees, for here it will be 5 rupees and here it will be 5 rupees. So with this approach, my total cost will be how much? 10 plus 15, right? Which is 25. And if I generalize in a formula, now if I generalize this in a formula, it will be cost of library plus. So if you see here, this problem is similar to the find total number of connected nodes. So this is total connected nodes 1, 2, 3, 4. So total connected nodes, but the roads are only 3. So total connected node minus 1. So this will give the total number of roads into its cost. So cost of making road. So this is how much? 10 plus total connected nodes is 4 minus 1 into cost of making the road, which is 5, which is 10 plus 3 into 5, which is 25, right? This will be the formula, right? So if you see here, this problem is already solved. Like we have already written the logic to find the connected components. So that's why I have explained those three problems so that you will get confidence to solve this problem. So 95% this problem is already solved here. Like we have this logic to get the total connected components. This is the size. We have this logic where we have written in this DFS, we have already written the logic to find the total number of size. So we have already written the logic to find the total size. So we will use this code. Now 95% this problem is already solved. So 5% is to take this input and create a graph. So the input format is like the very first line is like the query, like how many query user will give. So q is equal to 2 means there will be 2 queries. So this is one query where 3, 3, 2, 1. If you see here, 3 is n equal to number of cities, number of connected roads, cost of library and cost of road, and these are the connected nodes 1, 2, 3, 1, 2, 3. So this is the graph. So here we need to build the graph. Here they are not building the graph, they are simply accepting the values here, and they are calling road and libraries function with these cities. Okay, so we need to We need to write a logic here to create the graph, and then we will use this logic. And we will use this logic and modify here. So let us write the logic. So for example, the very first scenario is if my cost of library is less than or equal to cost of road, then we will simply return n into the cost of library. That's it. No need to check anything, or no need to create a graph as well. We will first check if cost of library is less than or equal to cost of road. Then what we have to do, we have to simply return n number of nodes into cost of library. That's it. So this was this scenario where we have used this logic. This one, where my cost of library was less than or equal to cost of making the road. So here the formula is very simple. We will simply return n into cost of library. Simply making libraries in each city is cheaper for us. Now, if this is not the scenario, then what we have to do, we have to create the graph. Very simple how to create graph. They are passing these cities, which is holding all the value. This one, integer array, which is holding all this value. This, all these cities value means the pair connected cities. So what we will do, we will take one graph equal to a dictionary. Okay, so that we can keep key and value pair. Now let's initialize this graph. So graph equal to, we will initialize, so this is a dictionary, so we'll initialize accordingly. So for I in range 1 to n plus 1 to include each and every cities. That's why we have given from 1 to n plus 1. We are including the n as well because the cities are from 1 to n. Okay, and what we will do, we will initialize with a empty list. Okay, so this is done. So let us print this graph so that it will be clear for you what we are doing in line number 30. Print this graph. So this graph will be initialized, like every key value will be initialized with a empty list. So let us print and see. Now next thing is we have to assign the value. So we have cities. So for u comma v in cities. So this city is having two value, u and v. So these are the value. I am making this 3 comma 4. 3 is u and 4 is v. Again 2 comma 4, 1 comma 2, 2 comma 3 and 5 comma 6. So left side value is u and right side is v. So for u comma v in cities, now what we have to do? It's like, so here we have cities like 1. So here we have cities like 1, 3, 3, 4, 2, 4, 1, 2, 2, 3 and 5, 6. So it will be like 1 is connected to 3. This is done. 3 is connected to 4. 3 is connected to 4. 2 is connected to 3. 2 is connected 2 is connected to 4. 2 is connected to 4. 1 is connected to 2. 2 is connected to 3. and 5 is connected to 6. That's it. 1 is connected to 3, 3 is connected to 4, 2 is connected to 4, 1 is connected to 2, 2 is connected to 3, and 5 is connected to 6. So how it will look in dictionary? It will look like, for 1 the values are 2 and 3. For 2 the values are 1, 3 and 4. For 3 the values are connected values are 1, 2 and 4. For 4 the values are 2 and 3. For 5 we have 6, and for 6 we have 5. So this is how it will look when we add in a dictionary. So for u comma v, in cities, if u not in graph, if u is not present in graph, means u as a key not present in graph, what we have to do? If u is not present in a graph, then what we have to do? Graph of u will be initialized with a empty list, and same if v not in graph, then what we have to do? Graph of v should be initialized with an empty list, and at the end we are going to add graph of u dot append v, and for v and for graph of v, this is very simple. I have already explained you in the first session. Graph of v dot append u, right? So this is how we generate graph. So print this graph at the end to check it's working fine or not. Print this graph. Okay, so it's like, I explain here, it's like if we are given these two value 1 and 3. So for if, like currently my dictionary is empty, right? So what it will do, it will go for a key 1, and initially it will be empty, and again 3 is also not present in this graph dictionary. So for 3 it will keep a empty list, and in the next line we were appending at key of u we were appending the value v, and at a key of v we are appending u. So this is how it works. So we are done with graph generation as well. Now our 5% task is done, and 95% task was already present here. Now till here we are done. We have generated the graph. So first scenario was where the cost of library was less than or equal to cost of making the road. Now here, if cost of making the library is greater than making the road, so what we have to do? Second scenario, if cost of making the library is greater than making the road, if cost of second scenario will be this one. If this sign is changed, if cost of making the library is greater than cost of making the road. So in this scenario, what we have to do? We have to traverse in every connected components and find the total number of cities, so that we can apply this formula where we will add cost of making the library plus count total number of connected nodes minus 1 to get the total number of roads, and we'll multiply the cost of making the road. So let us iterate in this city. So for city, for city in range, city is starting from 1 till n plus 1, where n is also included. So for city in range 1 to n plus 1. So what we will do? Let us take two variable here first. One is the visited, which will be a set, same logic which we have applied earlier for those three problems. And one will be, let us take total cost, let it be 0. Let us initialize with 0. So for city in range 1 to n plus 1, if city not in visited, if city not in visited, same logic which we have written here. If node not in visited, here we are simply writing city not in visited. So what we have to do, we have to simply call the DFS by passing the city, and this is the component size, this is the component size, so let it be like this only. And for the DFS, we have already written the logic over here in our previous session. Let us copy this code. So this was the reason I explained this problem separately, so that we can apply the same logic over here. So let us paste here. So so we are done with this. So this will return the size of the connected components. So we'll accept here component size. Now we got the component size. Now we'll apply the formula. Now we got the connected component size. Now let me explain you here. For example, suppose there are this kind of scenario where the connected components are 3. So every time we will be getting a connected components, connected components, connected components. So we have to write the formula for these connected components, again for this and again for this, and we have to add, right? Add the total values. So for that we will write total cost plus, like suppose there are 3 connected components. So for every connected components we need to find the total cost, and every time recursively it will get added. So total cost equal to, so total cost plus equal to cost of library plus component size minus 1 to get the total number of rows into the cost of road. So this is the main formula. So this is, for example, 2% of logic, and this was the 3% of logic where we need to create the graph, and 95% of the code was already done. And at the end we will return total cost. That's it, we are done. So this was the problem. So let us run this code and check. So it's failing cause of the indentation error, line 29. So we are done. So let us run this code. So you can see here it got passed. Now let us submit this code. So congratulations, all the test cases are passed. So this was the problem where we have already solved its interrelated problem like connected components count, print connected components, and find the largest component. So if you have already solved these three problems, means 95% of the problem was already solved, and 5% was like creating the graph and apply that smaller logic. So I hope you understood this problem, and if you learned something new, please do like our videos and subscribe to our channel Coding Card, and stay tuned for the next videos. Thanks for watching.